Okay, so welcome to the SAS Viya Transition Topics office hours. There are a couple of links on our screen to view previous training sessions and other offerings. You can visit that link. And then for more information about upcoming event dates and topics, you can visit that second link. And Laura is going to drop those in the chat in just a minute. So a few administrative announcements before I pass things over to Eddie today. This meeting is being recorded. Please remember to stay muted to minimize interruptions. Please use the Zoom chat feature to ask questions related to our office hours topic. And then all meeting materials will be made available in the CCSQ DNA portal after our event wrap. Just please remember to give us a few extra days to get that uploaded. Once all of our materials are 508 compliant and accessible, we'll be sure to get those over there. So with that, I'm going to go ahead and pass things over to Eddie and stop screen sharing so he can give you more information about today's topic.
Cool. Hey everyone, I just want to share the notebook real quick. I'm just trying to find the chat. Okay, here we go.
So at this point in the chat, Eddie has shared the notebook, and then Laura's also shared those couple of other links as well.
Okay, great. You guys see my notebook says office hours topic 13.
Yep, we can see it.
Okay, great. Okay, cool. So just real quick, my name is Eddie Chia. I'm a staff data scientist on the user services team. I've joined the team almost 4 months ago now. I have an undergraduate degree in statistics and a graduate degree in machine learning and artificial intelligence. I started my career as a stats programmer and a statistician, but I've made the transition to Spark and Databricks. So the the purpose of this office hours is to go over MatPlotLib, lib, and Seaborn, two of Python's visualization libraries. And so here's the quick agenda for it. We'll try to understand why we visualize data in the first place. We'll have an introduction to data visualization, the way I kind of approach it by asking myself 3 questions. We'll have key takeaways for effective data visualization. And then we'll have an overview of MatPlotLib that will include code and graphs, followed by an overview of Seaborn with the same thing. We'll have graphs and code. We'll do a comparison of Seaborn and MatPlotLib, and then we'll leave time for questions and answers. All right, so why visualize data in the first place? So enhanced understanding. Data visualizations transform complex data sets into intuitive, easy to understand insights. They help individuals quickly recognize patterns, trends, and critical information that may be hidden in raw data or spreadsheets. Quick decision making. So by presenting data clearly, visualizations facilitate rapid interpretation, enabling decision makers to act swiftly and confidently with accurate insights. And improved communication. So data visualizations simplify the communication of complex information, making it accessible and engaging for both technical and non-technical audiences alike. So how do I kind of approach exploratory data analysis and visualizations? I ask myself a couple of questions, right? So first one is, what type of data do we have? Do we have time series data, which is values recorded in a sequential order over time? Is it categorical, right? So do we have data group values based on kind of shared characteristics? Is it numeric, right? And if it's numeric, is it discrete or continuous? Depending on those answers, we're kind of restricted to specific graphs. And then finally, hierarchical data, which is structured with parent-child relationships, organized into a tree-like format. It's common in organizational charts, product categories, and file systems. Hierarchical data is often visualized using tree diagrams or nested structures. All right, so now that we know what kind of data we have, what message do we want to convey, right? The purpose of the visualization should inform the chart choice, right? So are we making comparison, right? Are we showing differences between categories? Are we displaying parts of a whole or proportions? Are we showing distributions, depicting how data spread across categories? Are we trying to show a relationship between or among variables and how they're connected? And finally, who is the audience, right? And what do they need? And so, depending if it's an analyst or managers, the final visuals will vary. So if it's an analyst, you might need more detailed data for in-depth analysis. So you might include some of the graphs that maybe we put in the appendix, later on. Managers require concise insights to make operational decisions. Executives prefer high-level summaries for strategic decision making. And then the general public. So if you have a public dashboard, let's say, looking for clear, engaging visuals that convey key trends. And then finally, some of the key takeaways that I've learned over the years having really just great managers, right? So prioritize clarity over variety. So choose the most effective chart types for your data, focusing on clarity rather than trying to include too many options. Customizations can be made later, but clarity should always be the priority. Eliminate noise to enhance focus. Remember that perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. It's interesting because that's a quote that I've now seen, I think, in 3 kind of visualization courses, and so I decided to go and include it here. He was a French poet, and so it definitely applies here. Strips away unnecessary elements that could detract from the main insights. And then finally, tell a story with the data. Create a narrative through thoughtful use of titles, labels, and annotations. This helps guide the audience through the data, leading them to the most important insights. Okay, so now that we kind of have that overview, what is MatPlotLib? So MatPlotLib is a popular data visualization library in Python used for creating static, animated, and interactive plots and graphs. It provides a flexible and powerful way to visualize data, making it easier to analyze and communicate insights from data sets. That's the main URL to Matplotlib. A lot of the information that you see in this notebook comes from there. It's the main resource that I go to, especially when I want to understand like the arguments within certain plots. All right, so the key features of Matplotlib, and really focusing on the first 3. First, it's a wide range of plots. It can create various types of visualizations, including line plots, bar charts, histograms, scatter plots, pie charts, and more. 2, customization, and hopefully some of the graphs that we see later on kind of highlights this feature. Matplotlib offers extensive customization options for titles, labels, colors, axes, legends, and more to tailor the plots according to user needs. And finally, integration, and we'll see this with Seaborn as well. Matplotlib integrates well with other Python libraries like NumPy and Pandas, which makes it a powerful tool for data analysis. And just to kind of, I guess, tease in Seaborn here, Matplotlib is the foundation for many other visualizations tools in Python, including libraries like Seaborn, which builds on Matplotlib to simplify complex visualizations. So we'll see that most of the cells that build out graphs tend to have both Matplotlib and Seaborn code in it to get my charts kind of the way I want them. Okay, so I feel like I do need to kind of add this here. We've seen this before. I think Chris had an OOP data camp maybe last month. maybe 2 months ago now, but it definitely applies here when we look at MatPlotLib and Seaborn, right? So MatPlotLib offers two primary approaches for creating plots, PyPlot and object-oriented programming, all right? You can see through the notes that I dive kind of deeper into the main reasons why, but I'm kind of fast forward to this table here to kind of give a high level of the differences, right? So when you look at PyPlot and the object-oriented approach, it's focusing on interface style. PyPlot function calls directly manipulate the plot, where OP it's interacting with objects like the figure and the axes. So PyPlot's looking at the entire kind of plot as a whole. The object-oriented approach is giving you the ability to format and update specific parts of the plot. And we'll see why that's really important when we start building out dashboards or, plots with multiple dimensions in it. Ease of use. So PyPlot definitely wins here. It's simple and quick for basic plots, less boilerplate code. For the OOP, it's more control and flexibility, but requires more code to set up. Code structure, PyPlot's less structured. It's ideal for quick plots and prototypes. The OOP is more structured, suitable for complex visualizations and larger projects.
Sorry to interrupt. Eddie, are you sharing your, like, for some reason, like I'm still stuck at the first cell, like you're still showing like the office hour topic. And I don't see.
Sorry about that. Let me try this again. Sorry, guys. I have it.
Oh, there you go.
I have it up on multiple screens, just if I lose track. Sorry about that, guys. So, just to kind of go up a little bit, yeah, we covered this, and now we're kind of going over the table here. Okay, cool. So thanks, Dan, for calling that out. Cool. So I think we're at customization. PyPlot limited customization of plot elements in one go. The OOP is more granular control over each element. Again, the axis, title, legend, etc. Flexibility, it's PyPlot's less flexible for complex plots or detailed customization. Again, it's for that kind of quick turnaround. The OOP is highly flexible, good for managing multiple plots and detailed adjustments. PyPlot, the learning curve is low for simple tasks. For OOP, it's steeper learning curve, but offers greater long-term flexibility and scalability. And finally, the use case, PyPlot, it's best for quick, simple visualizations, exploratory analysis. And then the OOP is best for more complex, organized, and reusable code, especially in larger projects. All right, so finally, when to use PyPlot versus object-oriented approach. Just to kind of sum up, like the table, right? So you use PyPlot when you need to quickly create simple plots with minimal code. You're working on a smaller project and doing EDA. You prefer simpler syntax and do not need detailed control over the plot elements. And then you use the object-oriented approach when you're creating complex visualizations that require fine control over multiple plot elements, working with large-scale project with reusable code, or need to manage multiple subplots or axes. And you need better organization of the plotting process, particularly when customizing figure layouts, multiple plots, or axes. So here, I am going to focus on the OOP approach. It is, again, like a steeper learning curve, and so hopefully we'll have a really good template with this notebook with the more common graphs that we use with some additional formatting. All right, so so the table that I decided to build the visualizations are in the CDR-PSA community schema, and it's the NYC MV crash cleaned table. When I was looking at the tables that were available for public use here, this one definitely caught my eye. And I'm not sure if I mentioned this in past like lunch and learns, but I was a bike messenger in New York City for about 12 years. Started, I think, my sophomore year of college, and then I took some time off between undergrad and grad school, and I continued throughout grad school. Definitely, I had my accidents, broke some bones, but it was, and probably still is, one of the more fun jobs I've had. So. The reason why I included the New York City subway map is because when we kind of dive into the graphs that lie ahead, I think it does a pretty good job to kind of understand the data or the graphs that we're seeing or the results that we're seeing. And it's really to kind of show that, um, Manhattan's pretty small, Brooklyn's pretty big, Queens is, even bigger with like less kind of trains going out there. The Bronx is small, and Staten Island is kind of on its own here with very limited access. I actually grew up off I think it's the D line now. It's changed around here. I went to high school around here in Bay Ridge. You can see my mouse. And then went to college at NYU here. What's interesting, just as a side note, is that even though I grew up in Brooklyn here, I really didn't know of this part of Brooklyn here until I got to college. There's a train here that kind of goes out here. But the reason why I'm bringing all this up is because as a bike messenger, I was really working here in Manhattan. Depending on the day, we'd split up basically Upper Manhattan and Lower Manhattan. But I lived in Brooklyn, had friends in Queens, and I would bike basically throughout here. So again, hopefully this will make sense after we see some of the results. Okay, so just real quick about the table I create. I actually create, I think, 10 or 11 different data frames to build out my graphs. And I think that's really just kind of highlighting how I approach visualization in the first place. For optimization and just kind of quicker turnaround, I do tend to create a data frame, not per graph, but definitely you'll see multiple data frames for the graphs that I build out. So just kind of quick call outs here in this data frame. Knowing that I wanted to build out bar plots, I wanted some more categorical features. And so I just wanted to kind of focus on this part of the code. Really, I just I extract crash month from the crash date, and then I create season using the months. I do the same thing with hour, extracting hour from crash time, and then creating a column called day part. So now we have winter, spring, summer, fall, and then morning, afternoon, evening, overnight, and then we can kind of dive deeper into some of those combinations in our graphs. And the other thing I wanted to point out is that I'm focusing here on COVID. So starting July of 2019 and ending at the end of June of 2020. But you can feel free to, I think there's about 6 or 8 years of data. All you need to do is just update these variables and everything should run. And finally, the table looks like this, right? So just to kind of go over, we have our crash date, we got a season, day part, we have our borough, and then the vehicle type code, contributing factor vehicle, and then our metrics. And it's persons injured, fatalities, and then persons is really broken up into pedestrians, cyclists, and motorists. I didn't use vehicle type code or contributing factor in any of my graphs, but if anyone wanted to kind of take what we built out here and kind of, build graphs using those, I'd be definitely curious to see what does some of those dimensions say. And then just quickly, I create a function here. It's useful for me. I definitely pass it on. I wish I would have known this when I kind of first learned Python, but whenever I'm doing exploratory data analysis, create this function where it kind of provides a shape, the info, and the head, provide an n parameter so you can control how many records are returned from the head function. All right, so the first thing I need to do for MatPlotLib and Seaborn, I need to convert that PySpark data frame into pandas. And now I'm, specifically choosing my variables. I convert crash date, do some aggregations, and we wind up with a data frame that looks like this by date, and everything's aggregated up. And it's weekly, sorry. I resample the data for weekly. All right, so the first thing that that we build out here, just using MatPlotLib, is a line plot. What makes this a little bit trickier than Seaborn, we'll see why later, is that we kind of have to create our lines separately here, where with Seaborn we have a hue where we can kind of add a category and it'll kind of break up those lines. But for here, a few things I just wanted to point out, right? So we're using the OOP approach, and I think every cell has this fig ax equals PLT subplots line of code in it. It's defining my figure and my axes, and it's also defining the size of the figure. And just plotting 3 line graphs like we see in the graph. And I try to, you'll see in the charts that I build out, I try to use different arguments so that by the end of the notebook, we'll have a really good understanding of a lot of arguments that we didn't necessarily use in one chart. So that if you were to go ahead and build another chart later, you can pick and choose from different charts what you want to use. But here we have the line width, the style, the color. We have the label, as well as the line style changes here again. We have our main title, and then we set the title, which is a smaller title, and then we set our X labels and Y labels. I provide 3 different lines of code for formatting the legend, and they kind of go in order of how I learned them, with the last one being the one I wish I would learn first. But it's really this B-box to anchor argument, and you'll see it used probably in most of the charts moving forward. But what this argument in the legend function allows you to do is really move the legend wherever you want, not just like in locations, but really giving it these kind of ranges. And you have to play around with it. It goes from 0 to, actually it goes above 1, and it goes to -2 if you want it outside, above, below the graph. And we'll see here that the 650 makes it in the center. The -15 goes below, like my date, and then the frame on equals false removes my border. And so that's something definitely that I wish I would have learned early on. If you were to use, the first legend, I think it pops up on the right side. It has a box around it, but it's actually located within the line plot itself. But now with this argument, that you can definitely really customize where you want that legend to appear. But just to kind of like forecast what we're going to see moving forward, we're going to see a lot of the same arguments as we build out these graphs, right? I think there are about 10 MatPlotLib charts and another 10 Seaborn charts. And the Seaborn charts, most of them are replicating what we saw in MatPlotLib, like just using Seaborn. But you'll see it's right, set title, set the Y label, set X legends, and then on some of these charts, you'll see these reference lines. But I wanted to add this here so that you could use it on your own graphs. And just to kind of point out here, this 18,332, it's just a number of days between January 1st, 1970, and the day that you want to highlight or reference. So this was March 8th, 2020. I used a calculator just to subtract the days, and it was 18,332, and that's where that vertical reference line appears. Same thing with the text. We have to actually move it back in time a little bit so that the S starts, where it starts, and you can see how that's added. But something that I thought early on, as I used Python and MatPlotLib, was somewhat difficult. It's actually not that difficult at all. So, and then this number 420 is just where it appears on the y-axis, right? And so 430 would have been off, I like to round up and down, so 415 would have hit the yellow. And so that's how we get the 420. It's where you are on the y-axis. Anyone, yeah, definitely feel to jump in if you have any questions. If not, I was going to move on to the next graph. Honestly, stacked line plots are not something that I often use in like my day-to-day, but I was playing around with this feature, and I actually thought it was really handy. And so, actually, honestly, I might start using it in my own analysis. But it's basically what we saw above in the line plot, except we're seeing them stacked, so we can see kind of clearly, out of all the people injured, when you break it down, it's the motorists or the actual people in the vehicles that are getting injured, followed by pedestrians, and then followed by cyclists. Very cool. Here's another function that I wish I would have learned earlier on in my kind of analytic career. Here I'm trying to compare number of injuries with number of fatalities across all of the boroughs. And what happens here often is that, the number of fatalities is so small compared to the number of injuries that you wind up with this kind of flat yellow line, and you're not able to see kind of the relationships, right? What you'd expect is that the more injuries you see, unfortunately, the more fatalities you probably see. But you don't see it just by kind of trying to plot two lines, right? So there's a function called a twin X. And I'm not sure if you guys have seen it before, but yeah, it's something I learned later on. And now we'll see how we can leverage it as we move forward, even with using Seaborn. But what we do here is, you create basically your first axis, and then you just create a copy of it. So now you're on the same axes, and then on that kind of cloned or twinned axis, you build your second plot, right? And so this would be fatalities. And again, with the OOP, right, you're tackling kind of each plot on its own. And so you're referencing either AX to set the Y label or AX to set labels and titles and things like that. And so what you wind up is what I think is a much more helpful plot where, even though, again, this is a good thing, fatalities are low, you do see somewhat of a kind of positive relationship between injuries and fatalities. But yeah, you can see how this is much more helpful than this graph up here. And again, we're just kind of using the same arguments, right, to create, reference lines. We're adding text here. We're removing spines, or reference lines, titles. What we're seeing in most of the charts in this notebook. So quickly, I create a new data frame. I just wanted to see barometrics. One of the things with MatPlotLib really is it doesn't really aggregate data like Seaborn does, right? So we'll see how sometimes you don't actually have to create data frames for Seaborn. It will do the aggregation as you build the plot out. Unfortunately, with MatPlotLib, you have to do the aggregations. And again, I like to do that anyway, just because it's probably easier on the plot function to just have the data that it needs to build that specific chart. And so what we're seeing here is just 5 records. We have all of our kind of metrics broken down by borough. And the first thing I want to do is just build the traditional bar plot by borough. And we're seeing that Brooklyn has the most injuries, followed by Queens, Bronx, Manhattan, and Staten couple of callouts that I wanted to make here is that, yeah, again, using the color argument here, this is how I went about creating that reference line, just to get the mean of that variable. And then again, setting the titles. I included, I think, rotation here for the first time. We didn't need it here, but if you do have like an x-axis that has a lot of records, if you do 45, you can see that it updates the labels accordingly. So even though I technically kept it at 0 here, in order for, I just wanted to include it there in case some of you run across that problem and you wanted to figure out how to kind of rotate your X labels. So it's kind of quickly, this makes sense. I live in Chicago now, and to be honest, I've been a little scared to ride my bike here. I am older too, but Brooklyn, it's a little bit, I guess, not good for cyclists just because there's a lot of traffic, a lot of big streets, and so it doesn't surprise me. A lot of highways, doesn't surprise me that that's the highest. And again, seeing where Staten Island is on that map, you can see why Staten Island is pretty low. Honestly, there's not much cycling or people riding their bikes out in Staten Island. All right, and then so do the same thing with that new date or season variable that we created. This time I just rotated it. So I just wanted to provide an example where we see horizontal bar charts. And you can see I'm playing with the alpha here. This just kind of lightens or darkens the shade of blue that we're seeing here. So if you were to put it at 1, I believe it'd be full color, and then this just makes it a little more transparent. Okay. So now here is again another example of twin X, but not using it not just with 2 line plots. We're laying line plots, a line plot over a bar plot, and so kind of the same thing that we've seen. The one thing I'm going to talk about here, which you might have seen it in earlier cells, is we're setting up our figure size here. Technically, I think this is 12 inches by 5 inches, and then I add this labels variable or object really, pedestrians and cyclists. And the reason why I do pedestrian and cyclists is because that's the order of my plot. So pedestrians first, and then it's followed by cyclists. You can do it this way, or you can actually add the label here. One or the other does the same thing. You will find why doing something like label equals might be helpful, especially when you're using trying to iterate over certain more than just two groups. But I just wanted to provide that there in case you see it in other code or you just wanted to try it. They basically do the same thing. You apply it here, and then in the legend, you apply it there, or you can apply it there. Okay, so just really focusing on the twin X again, but this time with the bar plot. We're using VBox to anchor. I don't think I mentioned this earlier, but the number of columns is important. That's going to be the number of values in your category. So in this case, it's just pedestrian cyclist, but you'll see where that goes up to 5 for borough, I think maybe 4 for seasons and later charts. But yeah, this is what gets it down to just these 2 columns. And you can see that that frame on equals true there, and this is how you get that frame around the legend. All right, cool. Yeah, so again, just to kind of hit it home, we have a vertical line, 18,332 days, the number of days between March 8th, 2020 and January 1st, 1970. And then 155 here is the location on the y-axis. All right, cool. So now getting into your kind of bivariate relationships. Here's your scatter plot. We're looking at the number of pedestrians injured by the number of cyclists injured. Again, playing with that alpha argument. We're setting titles, the X label, the Y label, and we're removing our spines for kind of formatting. And then this is what we get. We'll see a scatter plot using Seaborn, and Seaborn is my kind of go-to because if we wanted to, let's say, add a category, call this by category. Not sure we can do some MatPlotLib, where in Seaborn there's a hue argument, and it just adds another layer of information to your graphs. All right, cool. So this is basically a comparison of two histograms. We're looking at the number of injuries by pedestrians and by cyclists. This kind of supports what we've seen earlier. We're seeing less cyclists getting injured than pedestrians. And one thing I just want to point out on the data side, all right, we're seeing this kind of bimodal, this bimodal graph here. This is, again, like time series data, and so there are seasons here, and that's most likely the main reason why we're seeing bimodal. But yeah, here's, there's no need for that twin X. We're just creating two histograms, kind of one right on top of the other. And when I do these kind of bar graphs or, layover, I definitely choose a smaller alpha so that you can see it. Again, using that B box to anchor, frame on equals false, we get these, we get this legend here. All right, cool. So I wanted to see it by day part now. Basically, do the same aggregation. We get a day part data frame. It looks just like this. And we go ahead and create this kind of nice dashboard. The one thing I want to introduce here first is now that we're kind of getting closer to Seaborn, this SNS, short for Seaborn, set style. There's a lot of different options here, and you can see that our charts so far have been kind of just white. If we use dark grid, we can see now that our graphs are changing. And so, yeah, feel free to move this up to your first cell. I just wanted to kind of show that difference. And if you were just using MatPlotLib, or yeah, if you wanted to use MatPlotLib arguments, here's the MatPlotLib same argument. All right, cool. So the other thing I wanted to focus on here is that subplot argument. We've seen it, I think, in every cell, but up to this point, it was used to just focus on the figure size. Here, we're going to add these additional arguments that's going to help us create the dashboard. So the two, just like everything else in Python, the shape function, it's records, number of records, followed by the number of columns. And so we're creating a subplot here with two records, or two rows, I'm sorry, and two columns. So two rows and then two columns. And then, just to kind of share with the figure size, a lot of this was trial and error, right? I had to kind of, with the dates and the text, that a lot of that was trial and error. So 14 and 8 seemed to work out well for me, and then we just kind of approach it using the number of axes, right? So 0, 0, top left, 0, 1, top right. So basically the first record. Oh, sorry, Python index is on 0, but so yeah, the first column, so top right, 1, 0 would be bottom left, and then 1, 1 would be bottom right. And then for each specific chart within your dashboard, you're going to add text, you're going to add X and Y labels, you can add a reference line, you can add titles, and you can customize, however you want each graph. So first, line plot, I add the vertical line, reference line, I add some text, The second one, top right, is going to be a bar graph by borough. The second one is going to be a bar graph by season. I'm using horizontal bar plots here. And then the last one is going to be a horizontal bar plot by day part. And so you get, I think, a pretty informative dashboard with all of our data. So you can see the drop in injuries overall with COVID. And then you can see broken down by borough and then by season. Again, you see more injuries, summer, fall, more people are out. And then, evening, afternoon, when more people are out again. Once you start combining day part and season, we start seeing some pretty cool interactions. But all of this makes sense. And again, if there's any questions, yeah, definitely jump in. I'm going to go ahead and move forward. So, okay, fine. Finally, I think this might be the last one with MatPlotLib. But previously, the previous chart or dashboard, we used a subplot. Here, we're using specifically the grid spec method. The number of rows, number of columns is also a trial by error, but you want those to be kind of the same to get a square. And then for those who know Python and indexing, the first one is just telling you like the number of records beginning, like number of records you want this chart to fill. The second argument here, which is the colon, is basically using all the columns. And so basically this gives you exactly like the ability to really customize where you want to place your charts, right? So you want it to be just the top half, then you would use, maybe just a semicolon. If you want it to be separated, then you would have to kind of break down your columns and index accordingly. Any questions on that, just definitely let me know. It's more into how Python works and how you can index off that. But then, yeah, you just go ahead and apply all the formatting to each axis like you have them, and then you have this dashboard here. All right, cool. So when I first started using MatPlotLib, I definitely wasn't building dashboards or anything like this. But the more I used it, the more I learned from others and did my own research. I was able to start building these kinds of dashboards. And so, again, one of my goals here is to kind of create this template that you guys can then just drop in different data frames, different types of plots, adjust your legends and titles, and hopefully this will get you a little bit closer to your kind of final visualization. All right, so I know we have about 15 minutes left. Again, Seaborn, we will see a lot of the same graphs that we saw in MatPlotLib. But again, it's really just more as a template so that you guys can start leveraging, if you haven't already, building data graphs and charts using Seaborn. All right, so some notes here in terms of, what is Seaborn, why is it in certain situations better than MatPlotLib? And definitely when it comes to like statistical plotting, Seaborn, I definitely recommend Seaborn over MatPlotLib. Yeah, so just to kind of skip over those notes, going over the table, right? So MatPlotLib and Seaborn in terms of the ease of use, you can see MatPlotLib, it's just a lot more coding. We'll see with Seaborn, it's easier and more high level for statistical plots. Customization, Seaborn's less granular control, but good defaults. In terms of plot types, MatPlotLib is extremely flexible, supports all plot types. Seaborn focuses on statistical and categorical plots. Aesthetics, basic defaults, needs manual customization. Again, you just have to code, but again, once you get that kind of final template, then it's able to scale to other data. Data integration, Seaborn works seamlessly with Pandas data frames. The learning curve from MatPlotLib, as you can see, why it's steeper but more flexible, and with Seaborn it's easier but more user friendly. And so, given all that, if you need a quick graph, probably use Seaborn. If you're creating something for, let's say, a dashboard or maybe a presentation, probably better off using MatPlotLib to make those customizations. All right, just quickly here, I kind of make a Seaborn data frame. It has additional dimensions as well as the crash date and your metrics. The one thing I wanted to show here was with the line plot I mentioned earlier. So with the line plot, you do have this hue argument, and I included borough. So now we could see our line plots by borough, and from what we've seen in the earlier data, you can see that a lot of the boroughs with the higher injuries are in Brooklyn and in Queens, and we see that dip in COVID as well. Your error bar, this used to be CI or confidence interval. I'm not sure when the change was made, but now it's your error bar. I removed that so we don't see our confidence intervals here. But I wanted to share that because that is an argument. So if you were to make an update there, you would see it. And I think we do see it here. Yeah, so here's your bar plot using Seaborn. Again, you have your X, your Y, your data frame. Same thing, we're using MatPlotLib. Arguments or title. I did not use that error bar, and so we see our confidence intervals, and we see the percent of injuries by season. Now, here's one that I wanted to kind of focus on. What I did here was we have a bar plot, and the hue is day part, right? So it's just like the line plot, but it's now a bar plot, and because of the hue argument, we're able to see that day part. The one thing I wanted to point out is interesting is we see more injuries overnight and in the summer. I'm sorry, yeah, overnight in the fall and the summertime. But that goes, we see that kind of interaction, and we see now the morning kind of overtakes overnight. But just as someone used to ride their bike, it does make sense. It gets darker later, and it's really pretty to bike around with everyone else. So, but here's I think a pretty informative graph using those two variables that we created, season and day part, and we see that interaction happening. And that's really just SNS.barplot, and we have the hue. Here's your histogram, just kind of duplicating what we saw in MatPlotLib. And then I create a new data frame specifically for scatterplot and using Seaborn. And again, just focusing on the hue. So we have a number of motorists injured on the x-axis, a number of cyclists on the y-axis, and then the hue. Everything else we've now seen before. But again, we see Brooklyn and Queens out here in the top right. Going over statistical plotting, we have your box plots. The one thing I wanted to focus on here that we've probably seen earlier in the Seaborn section is that you can definitely sort your values here so that we can get that kind of sorted box plot. We have that reg plot that now builds out that regression line. But I'd rather use the LM plot, which is what I'm going to focus on here, because it does allow you to break up your graph by a category. And so using the LM plot and then the hue, we can see clearly, where Manhattan is kind of, we're seeing that steeper line. Staten Island is pretty short and flat, but it does a good job, seeing those relationships by borough. Finally, for this one, I just wanted to add this column argument here. Wouldn't say this is for like a higher level presentation, but if you wanted to see those charts broken out, you can see them there. It's like almost done here, but we have a joint plot, really good for seeing your distributions as well as your scatter plot. Here we're seeing it colored by day part, making sense. We see afternoon, top right. And then you have a pair plot. Pair plot correlation matrix, for me, always go hand in hand. This one's always followed by a correlation matrix. Some of the neat things here, is, the quorum equals true, so you just get half of the entire matrix. And then actually doing your aggregation here, something that not sure you can do it in MatPlotLib, but when you're using Seaborn, you can go ahead and create data frames on the fly like that. Finally, second to last correlation matrix. Again, none of this, I know it's only been half hour, but a lot of the stuff we've already seen. There is some formatting here of the column names to make them for presentation purposes, but again, we're seeing similar or some of the same arguments that we've seen before. This one just introduces the heat map. Definitely included in my EDA for all my analysis. Finally, you have this this facet grid. Does a really good job of giving you that dashboard look without actually having to do all those MatPlotLib codes or snippets of code. And then finally, we have subplots again, but we're combining MatPlotLib and Seaborn graphs. And we get this kind of dashboard where you have your line graph and we see that interaction between day part and season. So I know we're running a little bit out of time, but again, that was my main goal, was to really kind of share a template with you guys so that you can take this and run with it, build your own stuff. I left certain things unformatted, see if you guys wanted to work on those, but hopefully this will be a good resource for your future work in data visualization. I did include here the data camp resources to Chris's presentation on OOP, if you guys wanted to see that. If not, thanks again for your time, and are there any questions?
I don't see any questions at this point in the chat.
Okay.
I just want to thank you for making some of the data sets available. When I cloned it, I was still able to run those and get to the data sets. We've had problems with that before, where you use a bunch of stuff that's in your account, and for some reason they didn't give me the keys to everyone's account.
Yeah, no, thank you for saying that. At first, I know that we didn't have this communal kind of schema or location, and so we were kind of building our data frames on the fly, but it's much this way everyone's on the same page and you can run with it.
Again, thank you very much for doing this.
Welcome.
Eddie, are you okay at this point if I administer the survey?
Yep.
Okay, cool. All right. So just a quick thank you to Eddie for presenting today, and thank you to all of our participants. We're going to go ahead and administer a survey now. When you are finished, please feel free to go ahead and drop our call. But I did just want to hang on one second while I'm trying to find this on talk. I did just want to thank everyone for joining today, and please remind everyone to participate in our survey so we can continue improving our offerings and our office hours. So at this point, I'm going to go ahead and launch that. It should be on your screen now. Please make sure to scroll all the way through to see our questions and give us your feedback. Thank you so much.